Welcome to the SMRA podcast. I'm your host, Daniel Bader. Today's episode is a little different because we're on location in the middle school STEM room. Let me set the scene for you. It's after school on a Tuesday in one of the STEM rooms. There are boxes of stacked high on different tables. There are charts. There are work tables everywhere, and students are kind of filtering in. This is the first one of the first days of the NASA TechRise Program, and we're going to have students explain what that is. But I'm sitting in the room, and I asked for some volunteers, and two students step up to tell me what's going on. Here they are. Their names are Fatima and Kaylin. Well, thank you guys for volunteering to come on the podcast. What are we doing here? Fatima, what's the project we're working on today?
The project we're working on is it is a device that monitors VOC levels in the atmosphere. VOCs are volatile organic compounds that are basically dangerous gases that cause health problems like asthma, cancers, and even allergies.
And how are middle schoolers helping with that? What is this?
So we're a group of kids coming together to build sensors with also a camera and being able to, I guess, track these levels of it's not toxins. We're doing temperature, humidity, methane levels, benzene, formaldehyde, ozone, and we're going to monitor, I guess, those levels to see if that affects health issues.
We're going to launch it in Grant Park, or how are we getting it there?
So in, I think, May, we're sending it to NASA, and the launch is in, California or Florida?
California.
Basically, it's this big circle filled with everyone's boxes. There's 60 boxes, and they send them up to space, and they monitor all of them.
Yeah. Fatima, what brought you to volunteer in this for this project?
What brought me to volunteer in this project is when I first came to the school and started STEM for the first time, I actually had I was really drawn to it, so I wanted to do more and continue on with learning with electric engineerings, and I thought this would be the perfect program to pursue that.
Awesome. Yeah. How about you? What brought you to this program?
Well, so when I first saw this, when we first came to STEM, it was just a wire and a light bulb and a breadboard, and I was like, this is too complicated. And as we got more in, I was like, wait, I really understand this. I was like, I enjoy this because I'm focused. This is the one class I can actually do work in. So when she put the sign-up sheet, I was like, I'll do it. If this is what we're doing, I'll sign up and do it, just for the fun of it.
Have you guys always kind of been into science and technology, or is this new to you?
No.
You're both not.
This is our first year in this kind of stuff, so.
This is my first time ever trying anything with science and STEM, all that.
Are you guys good with computers, or with working with your hands, or did you know?
I've kind of always done small things with technology. My dad works on, my brother and my dad know everything about computers, so I always had that, and I was always looking into computers and stuff, but not what I expected here.
How about you?
I never knew I could because I never tried this before, and this is basically my first time ever doing anything with STEM.
After the students go back to their workstations, Ms. Mendiola passes the class to an assistant who's a volunteer from outside to start working with the kids and unpacking the boxes, and she takes a second to sit down with me. Here she is, Isabella Mendiola.
I started teaching STEM programs in 2009. I was one of the first teachers introducing the STEM programs in middle school, and the idea was to teach them coding and engineering prototyping. Also expose our students to more real-world application. So
what grades do you teach here?
In here, I'm teaching 6th, 7th, and 8th grade.
Oh, okay. You see each of them.
Yes,
Yeah.
the three. And the idea is to start with a foundation of electronics coding, so they can have this opportunity of participate in national contests like NASA TechRise.
How did you? Tell me what NASA TechRise is.
NASA TechRise is a national competition in which students participate by working in teams, collaborating, and designing projects that can be useful for the community. In this case, well, our project is monitoring the atmosphere. So they are designing and building a payload with different sensors for monitoring the conditions of the atmosphere, like air quality, basically.
And so you had to apply to be in this. Can you tell us about that application process? What was it like?
I applied in July, and I invited some of the students to participate, and they were very interested. They didn't have a lot of experience, but during our STEM classes, we were exposed to different sensors that they are going to use in the project, also coding, and we started designing the proposal, and in January, they gave us the good news that we won first place.
The first I'd heard about it was the announcement at the board meeting, the school board meeting. Congratulations! Can you tell us how competitive it was?
It was 720 entries, and we were one of the 60 that won the national. Wisconsin, the only one.
Wow.
So we are representing the state in South Milwaukee.
That is fantastic. I'm so proud of us, and we haven't even. They're just opening the boxes. Tell us about between now and when will they be working on this project, and where I should point out that we're talking after school, like students are working on this right now, not in class, right?
Yeah, we are working Tuesdays and Thursdays. We have our formal meeting with NASA on Thursdays. Tuesdays we use it for building and coding, redesigning the project if it's needed, testing, and of course checking the materials that we are using. Also, on Thursdays we receive the guidance of our mentors, the NASA mentors. So they explain what they are looking for, and they give us ideas for coding and engineering prototyping.
Wow. Tell me, who are they at NASA?
They are the group of engineers that actually are mentors, are teachers, and their job is actually guiding us for designing the code, designing the wiring, because sometimes we need to redesign our wiring, and they help us. They help us to do the test of every project, every sensor, and they give us ideas as well, and examples of how they can use the methane sensor, for example, or the formaldehyde sensors. They help us with all this information that we need for a project.
And so the two students who were on told me that they signed up for this. How did you introduce this to them?
I started actually talking about the main project during our class. My STEM class was actually designed for this type of national competitions, explaining about why they are using those sensors and those prototypes in my class for a specific purpose. Air quality, like NASA TechRise, water quality, depending the use. But always with a purpose. That my STEM class is, if we are going to use a sensor, has to be with a purpose. Air quality, water quality, soil quality.
Sure. Engineers almost to a person need a purpose, right?
Absolutely.
That's what you do. They are putting science into effect, right? And that's what you're doing. And what was their reaction when you told them that they were going to actually build something that was going to be used for real?
Yeah, they were really, it was, at that day I remember it was silence in the classroom. They were just in shock. They were like, oh my gosh, and tears,
Yeah,
excitement. Some of them, were, scared. They, well, what are we going to do? I said, don't be afraid. Just enjoy, because this one is what you have been doing in the classroom. You are going to do what you know, and you are going to learn more, and you are going to speak about your project, which is fantastic. It's wonderful. So
what's a STEM teacher's role in this project then? And I see you have a volunteer here helping you too.
Yeah, we are two mentors, and my job is helping them to have all the materials they need, helping them with the coding, with engineering prototyping, checking, of course, safety, the safety measures, and checking the engineering notebook, which is very important. That is one of the things that NASA emphasizes a lot, the engineering journal. We follow a structure, and that is actually our what we do every day. Every day is in there we write all our things that are working, things that are not working, the redesign, changes that we are making in our project. Has to be there. All has to be there.
Okay. And what are the benchmarks? Like when does this happen? When are you done?
We are finishing in May. In May, I need to send the payload built and tested to California, so where they are going to launch this payload with the other 60.
Yeah. How are they going to launch it? Is it a rocket? Is it a what is it?
It's a balloon.
Okay.
It's a balloon, and they are going to use that balloon for launching the 60 payloads. And our payload has a camera that actually is going to be taking video of our payload going to the atmosphere.
How high up is it going to go?
70,000.
Oh my gosh!
Yeah, so it's gonna be a. Like last year, has to be in the level of the stratosphere, actually. So from there, they're gonna start monitoring the conditions of these chemicals in the atmosphere. NASA TechRise, the launching is going to be in May, and that one is via Zoom.
Oh, I
Every
see.
parent, the schools, everybody has a link. Will get a link, and then they can watch the launching in May.
Well, that is almost the end of our episode for today. But I wanted to leave it with kind of the impression of what a real-world project has on students. So I'm going to end our podcast today where we started, talking to Kaylin and Fatima one more time about the what this means to them, and what the stakes are for their project.
When I signed up, I did not know that this is how far we were going. I was like, oh, we're building something. She was like, I didn't know what we were even doing. All I knew is we were building something, and then I found out it's for NASA, and it's like, oh, we're sending it to NASA. Oh, we have to do all this. It's like, oh, not what I was expecting. We're one in 60 schools. There was, I think, over 700 entries, and we're the only school in Wisconsin that won.
Yeah, we're the ones representing this whole state of Wisconsin, so it's kind of a pressure.
I want to wish good luck to our entire TechRise team and to the middle school and to Miss Mendiola. And I want to say thank you to them for being on the podcast. And thank you to you too for listening. This is the Yes to My podcast, and we will see you next time.